Hello students of the 9th standard. Today we are going to start our first chapter from the 9th standard science textbook. The name of the chapter is Laws of Motion. In this chapter we are going to study some concepts based on motion, acceleration, distance and displacement, as well as a very important concept in the study of science or in the study of physics, which is Newton's laws of motion. We will start our chapter with motion of an object. What is motion? It is the first question. Since we are going to study laws of motion, the first question which arises in our mind is, what is motion? There are two concepts, and we are going to study these two concepts in a comparative manner: motion and rest. They have, in the textbook they have given us few examples, and we have to classify these examples as motion and rest. I am reading the examples. The first example is flight of a bird, the second is a stationary train, third is leaves flying through air, fourth is a stone lying on a hill. You all can tell me that the first example, that is the flight of a bird, is an example of motion. The third example, the leaves flying through air, is an example of motion, and other two examples, that is a stationary train and a stone lying on a hill, are examples of rest. So we will now define what is a motion and what is rest. What is the difference between motion and rest? So in scientific terms, I am defining motion as motion whenever any object change its position with respect to surrounding, the object is said to be in motion. And the definition of rest is whenever any object do not change its position with respect to the surrounding, then it is said to be in the rest. Now we will see with the help of examples what is motion and what is rest. Suppose I am standing in a classroom. I'm standing in a classroom and I walk from one end of the classroom to the other end of the classroom. In this case, my surrounding is everyone. Every student who is sitting inside the classroom is my surrounding. Even the bench, the board in the classroom is my surrounding. I'm changing my position with respect to everything in my surrounding. For example, suppose I am standing in front of a classroom, then my position with respect to board must be around 1 feet from the board. But if I walked till the other end of the classroom, then my position with respect to the surrounding, that is the board, will change. Let's take another example. Suppose I am standing at the Virar station. I am standing near Virar station. Therefore, my position with respect to surrounding, which is Virar station, is 0 kilometers from Virar station. I started walking and I walked towards Nalasopara. I walked towards Nalasopara. I walked 5 kilometers towards Nalasopara. Therefore, now my position with respect to Virar station is 5 kilometers from Virar station. So whenever I change my position with respect to my surrounding, whenever any object changes its position with respect to its surrounding, it is said to be in motion. And whenever any object do not change its position with respect to surrounding, then it is said to be in the rest. Suppose a bottle is kept on a table. A water bottle is kept on a table. It means that water bottle is not changing its position with respect to surrounding. Means the position of the water bottle with respect to everything around it. The position of the water bottle with respect to the board, or the position of the water bottle with respect to benches which are kept near to it, will remain same. If the water bottle is at a distance of 2 meters from my position, then the position will remain 2 meters after a given interval of time. This means the object is in rest. Our next topic is a relative nature of motion. Relative nature of motion means an object can be the motion of an object depends upon the observer. Means for one observer an object can be in motion, and for another observer the same object can be seen as in the rest. Let's take an example to study relative nature of motion. Suppose there are three persons: person A, person B, and person C. Person A and person B are sitting inside a moving train, and person C is observing them from a platform. When person A will see person B, he will find that person B is sitting stationary, or he is in rest. And when person B will see person A, he will find that person A is stationary, or he is in the rest. But when person C, who is sitting who is sitting outside, or he is sitting on the platform, will see both of them, he will find that both of them are in motion. This is an example of relative nature of motion. That is, for one person an object is in the rest, but for another person the same object is in motion. We can take another example. Suppose I am standing on a ground. For everyone who is watching me from a surrounding, I am stationary. But suppose if an observer is observing me from moon, he's observing me from moon, then he will find that earth is revolving, or earth is rotating. Therefore, when he will find me rotating or moving along with the earth, therefore for everyone who is in my surrounding, I am stationary. But for the person who is observing from moon, I am in motion. Therefore, motion and rest are relative terms, means it depends upon the observer. Terms related to motion: distance, displacement, speed, velocity, and acceleration are various terms related to motion. In your textbook, you can find many other terms related to motion, like average speed, instantaneous speed, average velocity, instantaneous velocity, positive, negative acceleration. But don't bother about these terms. We just have to focus on distance, displacement, speed, velocity, and acceleration. Our first term, we are going to do a comparative study of these terms. First, we will study about distance and displacement. Comparative study will make it easier for you to understand these terms. So the first term is distance. Distance means path traveled by an object. Suppose okay, we will just see the definitions of distance, displacement, then we will see an example. With the help of that example, we will come to know each and every term. The distance is the path traveled by an object in motion, which is generally denoted by d, and units which are used to measure distance are meter, centimeter, kilometer. If the distance is very small, it is measured in centimeters or millimeters, and for the larger distances we use units, kilometer as the unit. Displacement is similar to the distance, but the definition of the displacement: what is displacement? The displacement is the shortest distance between initial and final position of an object. The displacement is denoted by s. The units for displacement are meter, centimeter, and kilometer. The speed and velocity, the relationship between the speed and velocity is similar to that between the distance, between distance and displacement. Speed is, we can easily compare them by using by seeing the formula for speed and velocity. The formula for speed is distance upon time, and formula for the velocity is displacement upon time. That means we can it is easier to say that speed can be calculated by using distance, and velocity can be calculated by using displacement. In other words, you can say that speed is the next step of distance, and velocity is the next step for displacement. Okay, so the definitions for speed: it is the distance covered in unit time, means distance covered by a body in unit time. And the definition for velocity is displacement covered by a body in unit time. The units can be made by using formula. The formula is distance upon time. Therefore the units for speed and velocity are, the unit for distance is meter, and unit for time is second. Therefore the units for distance and time are meter per second, centimeter per second, or if the unit for distance is kilometer and the unit for time is hour, then the unit is kilometer per hour. So with the help of one example, which I will with the help of an example, now we are going to study distance, displacement, speed and velocity. Suppose a person is traveling from point A to point B, which is in the right of point A at 3 kilometers, and from B he travels to the north, or he travels in the upward direction 4 kilometers towards point C. Now we have to calculate the distance, displacement, speed and velocity if he took 1 hour to complete his journey. So therefore the distance is the actual path length traveled by the person. The person has traveled from A to B and from B to C. Therefore path traveled by the person is 3. First he traveled 3 kilometers and then 4 kilometers. Therefore the path traveled, or the distance covered by the person, becomes 7 kilometers. And if you have to convert it into meters, then it is equal to 7,000 meters. The displacement of the object. Displacement means the shortest path between initial and final position of the object. The initial position of the object is A and the final position of the object is C. You can see in the diagram that the shortest path is the diagonal or the hypotenuse of that triangle, which is AC. So by using the Pythagoras theorem, we can calculate the distance of the hypotenuse, which is AC, and which is equal to the displacement, which is the shortest path between the initial and final position of the object. So the displacement becomes square root of 3 square plus 4 square, which is equal to square root of 25, which is equal to 5 kilometer. Therefore the person has covered a distance of 7 kilometer, but his displacement is only 5 kilometer, which is equal to 5,000 meter. Now we have to calculate speed. Speed means distance, the rate of covering distance, which is he covered a distance of 7 kilometer and took a time of 1 hour. Therefore the speed is equal to 7 kilometer per hour. 7 kilometer divided by 1, and if you have to convert it into meter per second, then we just have to convert 7 kilometer per hour into meter per second. That is 7 kilometer, which is equal to 7,000 meter, and 1 hour, which is equal to 3,600 seconds. So we can also calculate the speed in meter per second. So while solving the problems of motion, we come across a difficulty of converting the velocities which are given in kilometer per hour to meter per second, and vice versa. That is, if the velocities are given in meter per second, we also have to convert them into kilometer per hour. Generally, or commercially used unit of velocity or speed is kilometer per hour, and scientific unit of velocity is meter per second. Generally used unit, that is SI unit of velocity or speed, is meter per second. So to convert kilometer per hour into meter per second, we have a value, that is 5 upon 18. How it comes, that is given to you in the notes, that 1 kilometer per hour is equal to 5 upon 18 meter per second. Therefore to convert a value given in kilometer per hour into meter per second, we have to multiply it with 5 by 18. And to convert, if the values are given in meter per second and we have to convert them into kilometer per hour, then we have to multiply it with 18 by 5. We have also given you two examples. That is, in the first case, that is the velocity of the object is 18 km per hour, and to convert it into meter per second, we have multiplied it with 5 by 18. The answer is 5 meter per second. Therefore 18 km per hour is equal to 5 meter per second. And in the second case, we have given the velocity, in meter per second, which is given as 50 meter per second, which is equal to 50. To convert it into kilometer per hour, we have multiplied it with 18 by 5. So 50 into 18.5, which is equal to 180 kilometer per hour. Therefore 50 meter per second is equal to 180 kilometer per hour. We will solve some more problems. As an exercise, I will give you some problems of conversion of kilometer per hour into meter per second. Next point is uniform motion and non-uniform motion. Motions are of two types, uniform and non-uniform motion. Uniform motion means when an object covers equal distance in equal interval of time, and non-uniform motion when an object covers unequal distances in equal interval of time. Let's take example of two persons running a race. Let's first see the motion of person A. Person A starts the race. In first 20 seconds he runs 100 meters. In the interval of next 20 seconds he runs 100 meters again. In the third interval also he runs 100 meters, and in the fourth interval also he runs 100 meters. But the motion, but when we observe the motion of person B, in the first 20 seconds he runs 150 meters. Then gets tired, and in next 20 seconds just runs 20 meters, and then in the third interval of 20 seconds he runs 100 meter. By observing both these motions, we can easily conclude that the motion of person A is uniform motion, and motion of person B is non-uniform motion. The next point about uniform and non-uniform motion is the motion. In the uniform motion, the velocity always remain constant. You can see that when person A runs from point 1 to point 2, his velocity, we can calculate velocity by using the formula distance upon time, or displacement upon time. His displacement is 100 meters and the time taken by him is 20 seconds. Therefore the velocity is 100 upon 20, which is equal to 5 meter per second. In the second interval, that is from 2 to 3 also, his velocity remains 5 meter per second. In the third interval, that is 3 to 4, his velocity remains 5 meter per second. In the last interval also his velocity is 5 meter per second. But when we observe the motion of person B, we can see that in the first interval, that is from 1 to 2, the velocity of person B is 150 meter divided by 20 second, which is equal to 7.5 meter per second. But in the second interval, the velocity of person B is 20 meter divided by 20 second, which is equal to 1 meter per second. And in the third interval, his velocity changes to 5 meter per second. So we can see that the velocity of person A remains constant, whereas velocity of person B is changing at every instance, or it's changing at every interval. Therefore the motion performed by person A is said as uniform motion, whereas the motion performed by person B is said as non-uniform motion. Next important term related to motion is acceleration. Acceleration, we can define acceleration as acceleration is the rate of change of velocity. The formula for acceleration is change in velocity upon time. But why does the velocity changes? We have seen uniform and non-uniform motion, but you can recall any of your motion when you travel from your home to the classes. When you travel from your home to the classes, you can easily see that your velocity changes at every instance, or your velocity continuously keep on changing. We do not, our motion is not always uniform motion. Our velocity keeps on changing. Sometimes we walk faster, or sometimes we walk slower. Even the velocities of the vehicles while traveling in the traffic, while traveling in the heavy traffic, the velocity of vehicle changes. It gets reduced, whereas if the road is empty, then the vehicles travel with a higher velocity. That is, the velocities of the vehicle or velocities of every object keep on changing. So therefore, by what amount or by what rate the velocity of the object is changing can be found or can be calculated by using the acceleration. The formula for acceleration is change in velocity upon time. You can see in the notes that formula for acceleration A is equal to V minus U divided by, it is given as V minus U divided by T. whereas v is the final velocity. If you have to find a change in the velocity, the change in the velocity can be found by subtracting the final velocity from the initial velocity. From an example also we will see this. So in this example, person A is traveling from A to C. First he is traveling from A to B. His initial velocity, when he starts his journey, or when he starts his motion, his velocity is 0 meter per second, and in the next 10 seconds he increases his velocity from 0 meter per second to 30 meter per second. When he reaches B, his velocity has become 30 meter per second, and then he further in next 20 seconds he further increases his velocity from 30 meter per second to 50 meter per second when he travels from B to C. Now let's calculate the acceleration, or acceleration means rate of change of velocity, means how much, by what rate the velocity is increasing between interval A to B. The formula for velocity, the formula for acceleration is final velocity minus initial velocity divided by time. In this case, in the journey between A to B, the final velocity or the velocity at the end is 30 meter per second, and initial velocity is 0 meter per second. Therefore, by using the formula we have calculated the acceleration as 3 meter per second square. In the second case, that is the motion between B to C, the initial velocity is 30 meter per second and final velocity has gone to 50 meter per second. Therefore, the acceleration is found to be 1 meter per second, because the time required for this journey was 20 seconds. Therefore 50 minus 30 divided by 20 comes to 1 meter per second. And similarly we have calculated the acceleration of the body of the object between A to C, which is found to be 1.67 meter per second. In the first example, that is from A to B, the acceleration is found to be 3 meter per second square. Its literal meaning is that the velocity of the object is changing by 3 meter per second every second. 3 meter per second square means 3 meter per second, means velocity is increasing by 3 meter per second in each of the second. That is, when the object started, its velocity was 0 meter per second. In the first second, the velocity increased to 3 meter per second. In the second second, the velocity increased to 6 meter per second. In the third second, it increased to 9. In the fourth, it increased to 12, and in the 10th second, its velocity increased to 30 meter per second. That is, the rate of increase of the velocity is 3 meter per second, that is 3 meter per second square. The increase in the velocity can be negative also. It is called as negative acceleration or deceleration. We will further extend this example from C to D. An object is traveling from C to D. It is taking 10 seconds, and in these 10 seconds the velocity is now decreasing from 50 meter per second back to 0 meter per second. And let's calculate the acceleration in this case also. We can easily see that acceleration between C and D, the final velocity is 0 and initial velocity is 50. Therefore its subtraction becomes minus 50 meter per second, minus 50, and the time taken is 10 seconds. Therefore here the rate of acceleration is minus 5 meter per second, meter per second square. The rate of acceleration is negative because here in this case the velocity is decreasing, and such case is called as negative acceleration. This happens when brakes are applied. When accelerator is pressed, the acceleration takes place, that is velocity increases, and rate of increase of velocity is positive. But when brakes are applied, acceleration is negative, that is the rate of change velocity decreases, that is acceleration is negative, the rate of change of velocity is negative.